This is solving, or simplifying, I should say, exponents. And so I gave out this sheet in class. I'm going to kind of walk through it. Here it asks me to write without any exponents. And so when I see p to the fourth, it means I have 4 p's being multiplied. And I have 2 q's. And then in the second parenthesis, I've got 3 p's. And I have 5 q's. And yes, I don't have enough space. So when I write all those out, that's what it asked me to do right here. So this is to show you what's happening. And right here they asked me to count up the variables and write with exponents. So notice I have 1, 2, 3, 4, 5, 6, 7 p's. So I have p to the 7th, meaning I have 7 p's being multiplied. Then I need to count up the q's because I only do this by the variables. So I have 1, 2, 3, 4, 5, 6, 7. I have the same number this time. Okay, the second example, I'm going to write it down here. So I have 2 m's and 1, 2, 3, 4, 5, 6 n's. And then I have 3 m's and 1 n. Again, I'm writing without the exponents, so I have to write it all out, which the point is we want to get annoyed with that so that we can come up with a rule that will always work. I have 1, 2, 3, 4, 5 m's. And I have 1, 2, 3, 4, 5, 6, 7 n's. Okay, so we came up with a rule that said when you're multiplying, because initially these problems are multiplication. And we said with the same base, remember the base is the p, the base is the q, base is m, base is n. Okay, so I didn't, let me explain that. We added the exponents. Here's what I mean by that. I did not go say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The same base. So I picked all the p's, that's the base, and I added them up. If you look right here, 4 plus 3 gave me the 7. 2 plus 5 is also 7. When I look at these, m has 2, m has 3. 2 plus 3 is the 5. This n has 6. Don't forget that this n has a 1. So 6 plus 1 is where I got the 7. So that is multiplication. When I want to do division, same thing, 1, 2, 3, 4. Okay, and this is my division bar right here, so I've got 2 A's and 3 B's. Now I'm going to remind you very quickly that when you divide something by itself, let's say I have 5 divided by 5, that is 1. If you have 5 pieces of pie for 5 people, everybody gets 1. Negative 10 divided by negative 10 is also positive 1. So that means if I have x divided by x, anything divided by itself is 1. Some students don't remember that, but a variable divided by itself is going to be 1. If I have x over x, and I tell you x is 3, and this is 3 divided by 3, which is 1. Okay, how does that apply right here? That means that I have a divided by a, it's 1. A divided by a, it's 1, or we call that canceling out. B divided by B, B divided by B, B divided by B. They cancel one another. So what I look at is there are 2 a's left, and they are left in the numerator. So I'm going to put a squared in the numerator. There's 2 of them. There's 1, 2, 3, 4 b's, and they are also in the numerator. Notice nothing's left in the denominator. So technically it's over 1, but we would normally just write that like this. Second example, I have 4 x's, and I have, 5 y's. And in the denominator I have 9x as well. See, we don't want you to do this all the time. It's kind of annoying. You can to work the problem, but it's a lot of work. So when I'm ready to cancel, anything divided by itself. So 1, 1, 1, 1. Y is 1, 1, and there's nothing else. So this is important. I have a numerator and I have a denominator. In the numerator, I've only got 1, 2, 3 y's. So that's y cubed. In the denominator is where the x's are left. 1, 2, 3, 4, 5. So the rule is when we're dividing, again with the same base, we don't look at all the variables, just individual bases, we're going to subtract the exponents. So when I look here, 4 minus 2 left me with 2. 7 minus 3 left me with the 4. On this problem, do you notice x is larger exponent in the denominator? So my job is to leave the x in the denominator and do subtraction from here. 9 minus 4 is 5. Because it's larger in the denominator, x stays in the denominator. Between the y's, it's larger in the numerator, so y stays in the numerator. And 5 minus 2 is 3. Okay, last example here. So on this problem, I've got r cubed s to the 4th. I'm going to write it like that. And they want it 3 times. Okay, so that cube means that I'm going to write it 3 times. So I know that I have 3 r's, 3 r's, and 3 r's. So that's 9, because you can add, right? We're multiplying now. 3, 4, 5, 6, 7, 8, 9. For the s's, I have 4. That's 8, 12. Okay, for the second example, I've got c squared, d squared, but they want that 4 times. And I'm going to have to write one more down here. Okay, so I have 2, 4, 6, 8 C's and 2, 4, 6, 8 D's. So here, when you have a power is another word for exponent. So when you have a power raised to a power, notice I have a power or an exponent raised to another power right here. We're going to multiply the exponents. Notice that 3 times 3 is 9, 4 times 3 is 12. 2 times 4 is 8, and 2 times 4 is also 8. Okay, down below I'm not going to spend a lot of time here, but what I do want you to recognize, what students do is they look up here and they say, hey, I'm multiplying, so I'm going to add the exponents. That is true. So I'm going to have x, 2 plus 1 is 3, and y, 3 plus 1 is 4. But then they say 4 plus 7, and the important part is 4 and 7 are not exponents. So they don't follow this rule. This is for exponents, little bitty guys, little people. So I just do 4 times 7, known as 28. Okay? On this problem, u to the 4th and u to the 3rd. And I'm multiplying, so I'm going to add that. 4 plus 3 is 7. I've got w squared and w squared. When I add, I get 4 of them. 5 is multiplying by a 1 that is the coefficient here, so that is still 5. I do not add 5 plus 1. 5 is not an exponent. It doesn't follow an exponent rule. Okay, on this section here, I'm dividing. So I'm going to ignore the 3 and 15. They are not exponents. When I look at the f's, f is larger in the numerator. So I'm going to leave f in the numerator. And 5 minus 2 is 3. G is larger in the numerator. 3 minus, that's a 1, is 2. But when I divide, and I can use my calculator for this, 3 and 15 are not exponents, so 3 divided by 15. The answer is not allowed to be a decimal because they gave me a fraction. So I'm going to hit math, enter, enter, and I get 1 over 5. Notice the 5 is in the denominator. So when I come back here and I write this, I need to put this over 5. You can put a 1 here. Don't have to. But this is the correct answer as a fraction. 3 goes into itself once, 3 goes into 15 5 times. Okay, on this problem here, again, I'm going to ignore the whole numbers, the coefficients. A is larger in the denominator, so I'm going to put it in the denominator. And 4 minus 2 is 2. B is larger in the numerator. Notice I put it there before I did anything else. 6 minus 3 is 3. And then I'm going to deal with the coefficients. So I'm going to use my calculator. I'm going to say negative 8 divided by 2. Maybe, if you can see that. There we go. And I'm going to get negative 4. Negative 4 is in the numerator because there is no fraction. So negative 4 will go up here in the numerator because they did not give me a fraction. That's my answer. Okay, last part of this to make sure you do this right. We have exponents with exponents. That means we're multiplying. So I'll ignore the negative 5. It is not an exponent. So x, 2 times 2 is 4. Y, 4 times 2 is 8. Squared means that I should have written this. I just want to show you 2 times. So you can write it out if it helps you. And notice that that is negative 5 times negative 5. I am not doing negative 5 times 2. That is an exponent. That is not. Coefficient, exponent. So negative 5 times negative 5 is positive 25. On this bottom problem, I'll write this one out. So you're doing 4p cubed, 4p cubed, and 4p cubed. I'm writing it 3 times because it asked me to. So I'm going to ignore the 4's. P. I've got p cubed, or 3 times the 1 is still 3. 3, 4, 5, 6, 7, 8, 9. Q to the 9th, or 3 times 3 is 9. But I do not do 4 times 3. 4 is not an exponent. So how do I do that in the calculator to make sure I get it right? I would say 4 raised to the 3rd. That 4 is being raised to the 3rd power, and hit enter. Or 4 times 4 times 4, because I wanted a 4th 3 times. That is 64. That is not 4 times 3. 4 is not an exponent. Those are the rules for exponents. Use that to work on the extra assignment provided.